CH3, CH2, remaining all hydrogen. So according to that, because it depends on what is the question asked in the exam. They may ask about butene, they may ask about pentanol and hexanol. Accordingly, you choose that. Okay, so you should remember the general method. So whenever alkene is taken, there will be a double bond. So here once H2O, H2O means HOH. Okay, H2O is added, and very sure that you will get. You see this is now the two valencies I am writing here, and here the two valencies, and here one side hydrogen, one side OH. So now this becomes alcohol. Alcohol. Okay, so this is alcohol. This is alkene. Right? So now here only one point you have to say whatever alcohol you want you can take, but only thing is how the addition takes place. You know, the temperature conditions, dehydration only. Right? Now here this in acidic medium. Okay, so in acid catalyzed that we will be using generally sulfuric acid. Sulfuric acid will be used for providing H plus. Okay, acid catalyzed reaction. Hydration, addition of water is called hydration, right? So now here, suppose only one thing you have to note down, that is how there are two types of addition. That one is Markovnikov's addition, another one is anti-Markovnikov. So here the addition is according to Markovnikov's. Okay, Markovnikov's addition. KOD or KOWF also you can use Markovnikov's addition. I have shown only the double bond side. Suppose it is unsymmetrical, water though it is unsymmetrical. See, for example, CH3, CH double bond CH2. Okay, so this is propene. And plus KHOH, water. H plus OH. This is unsymmetrical. This is also unsymmetrical. All of you should know there should not be any question in your mind. Why one can talk about Markovnikov's addition. So far you don't remember exactly names. So now at least remember, don't forget. One can talk about Markovnikov's addition. Similar to this, when you will talk about Lee-Chatelier principle, can anyone tell me when you will talk about Lee-Chatelier principle?
Equilibrium.
Only when equilibrium. Okay, so if any chemical reaction has not attained equilibrium, it is going in the forward direction or going from the product side to reverse direction also, sometimes it will be possible. If it is not attaining equilibrium, nobody can talk about Lee-Chatelier principle. So that point should be known to you. Simply you can't speak about Lee-Chatelier principle everywhere. Lee-Chatelier principle is applicable only for a reaction which is at equilibrium. Similarly, Markovnikov's addition one can speak about only when the reactant and the reagent, the substrate and the reagent. Substrate is alkene, reagent is anything. If you add water, HOH. If you add HBr, HCl, you can add Cl2, Br2 also, but there Markovnikov's addition is not applicable because they are symmetrical. Any unsymmetrical, HCl, hydrogen cyanide, that also can be added so that the cyanide, nitrile you will get. So unsymmetrical substrate and unsymmetrical reagent, then Markovnikov's addition possible. What it says, the negative part of the addendum. The negative part of the addendum. Addendum means what? Addendum means one which is getting added. Here the addendum is KHOH. Negative part means what? This is plus minus. That means OH minus. The negative part of the addendum will add on to the least hydrogenated carbon atom. Least hydrogenated carbon atom means carbon carrying less number of hydrogen. Least hydrogenated carbon atom. Suppose there is a double bond, carbon-carbon double bond. That is least hydrogen means between these two carbons. Okay, so here if suppose this is having H, this is having 2 CH3. And here it is having another one carbon. That means now see that in this carbon only one hydrogen. In this carbon no hydrogen, no hydrogen. That means least hydrogen. So here only that what will be added? That OH will be added. Here hydrogen will be added. That is the meaning. So according to Markovnikov's addition, the reaction will take place. So here the product is CH3, CH, CH3, and here only OH will be added. So you will get isopropyl alcohol, isopropyl alcohol, or propane 2-ol. So if anybody wants, during the conversion, anybody wants propane 1-ol, immediately what you do? Here you write peroxide, so that anti-Markovnikov's addition. So as per your requirement, this reaction normally when you carry out Markovnikov's addition, you want the addition to be in opposite to Markovnikov's addition, then you use peroxide. Simply you put above the arrow mark and below the arrow mark you write peroxide. That's all. Then the product will be according to anti-Markovnikov's Karosh effect or peroxide effect we say. Okay, so this is one thing. And this point you note down. Now next is about the mechanism. Okay, one should know the mechanisms. Can anyone tell me what is the meaning of mechanism in organic chemical reaction? What is mechanism? So that is sequential, stage-wise explanation for a reaction. Is it a theory or any method, any experimental method is there to find out? Anyone of you?
Theory.
Is it a theory? It is a theory. Because that when you take substrate S and reagent, and it will form the product. Directly it will form the product. But that you know what is substrate, you know. What is the reagent, you know, because it is a known substance, you know the structure, you know the properties, everything, atomic connectivity. The reagent also, you know, and then product you are getting newly formed. But after that class you study in class 11, what you will do? You will purify, then you will get the percentage, then you will get the molecular formula. But after that you did not study, but in graduation you will study that it will be molecular formula, then after that you will come to structural formula, how the atoms are connected. Okay, so any new compound you can get the structural formula also. That means what is for any reaction, you know substrate very well, you know reagent very well. After getting a new product, even if you are doing a research work, you are getting a new product first time. Then also by different method, experimental method, spectroscopic method and other method, you will come to know about the structural formula, how the atoms are connected. So if you know the substrate, reagent as well as the product, everything, then you will be able to propose a theory, because you cannot see, no device we have to see how the atoms are breaking, how the bonds are breaking, atoms or ions are coming out and where they are attacking. Nobody can see. So by using this knowledge of the structure of reactant and structure of product, you can propose a theory explanation. That is only theory. Okay, but the theory is, I told you, always in agreement with some experimental result. What is the experimental result? Here the reaction only, experimental result. So it will explain. So here they have proposed a theory. There are 3 steps involved in this theory. So you write down, you also write down, better you write in separate paper or pages. So there are totally 5 mechanism will come, and definitely one mechanism will be asked always in the exam. Okay, so write down. The first one is protonation of alkane. Step 1 is protonation. Please don't forget, in many of the cases, the protonation will be common step. Protonation of the reactant, that is alkene. Protonation of alkene. Right. So here I just take the example. C, and I think I will directly take ethylene. Okay. Ethylene I'll take. right? And this H plus protonation means adding proton. H plus is proton. That is only protonation. That is how that addition will take place, and this one. See that this will be, so this proton will be attacking this pi c because this is electrophile positive charge and the double bond is negative. So it will attack here, means any one of the side it will get attached. Okay, so that is which side it is getting attached. You write any side. So see, now you can bring it like this once because here hybridization will change. So because the double bond is going to disappear. So here one hydrogen, here one hydrogen, and here one hydrogen. This hydrogen that newly comes, this hydrogen. Okay, so and that automatically positive charge will come here. So don't forget that positive charge will come here. Why? Because you see these two electrons, one electron is this carbon atom and another electron is this carbon atom. But once it is going to the CH bond, that this carbon, the right side carbon is still holding its contribution, that electron, but the left side carbon is completely losing its electron for that one. So here it will be carbocation. Okay, so there will be a carbocation. Okay, so the space is not that's why I will be telling the steps in notes and you write down. Okay, the next one is step 2. Step 2. Okay, write down nucleophilic attack by water on carbocation. So write down the heading nucleophilic attack. So nucleophilic attack means that water OH2 will have 2 lone pairs of electrons. So this will attack. Okay, it will attack whom it will attack? It will attack the carbocation. The carbocation is already formed in the first step. Okay, so now this is the structure I am writing. CH, and here there is a positive charge, carbocation, C, H. Okay, so now this side I am writing O, H. This is water molecule will have 2. So now I am using this right. This will attack this. Okay. So once it is attacking, what will happen? Once it is attacking, see that this I am writing the whole structure: carbon, hydrogen, and here this carbon having 3 hydrogen. And only that positive charge site is attacked by oxygen of water. So water will be having 2 hydrogen. Now can you tell me where the see that positive charge will not disappear? That you remember always, any mechanism when you write, when positive charge is present, it will not miss in the right side. It will miss in the right side only when there is a negative ion joined. Okay, when negative ion is joining, then it will be missing. Otherwise, it will not dissolve. It will be moving from one place to another place. Can you tell me that where is it now? Where is that positive charge? In oxygen atom, because oxygen atom electrons only used for bonding. So overall net effect is oxygen will be losing 1 electron. So the positive charge will be right. Okay, write down. Now step 3, deprotonation. Step 3, write down. Step 3, deprotonation. Means the proton came in the first step, and now the deprotonation means proton is going to depart, that it is going to move from this last product what you have written. Okay, so write the steps. Step 3. This is deprotonation. Right? For that I am writing this H, C, H, C, CH3 I am writing. Here O, H, H. Who is that? Who is the errors? So this positive charge is here. Right? Now how to show that, because in that this arrow mark, whenever you use this arrow mark, this is 2 electrons are moving from which place to which place. Okay, so this is from the tail part is from which place it is moving. Last time I have told you that A, X, If it is electron, it is a plus pi bond. If it is coming like this, means what is that? A double bond X, okay, and then X will get a positive charge, this will get a negative charge, because A is getting one extra electron, X is losing its electron, so positive, negative, like that it will form. Overall, 0, here also no charge, like that. Some that type of electron movement has been taught to you. Once again, go through that. And if you use that half-headed arrow mark, that may not come now in mechanism. Half-headed arrow mark means one electron movement. Generally, suppose one carbon bond is there. So here, if you use this symbol, this represents the bond is breaking. The arrow mark is the indication is bond is breaking. One electron goes to this carbon, so this carbon. Another electron comes to this carbon, so you will get a free radical. That is each. This is the indication. Full-headed arrow mark, and the curved arrow mark, and the curved half-headed arrow mark. Meaning is this one. Right, so here you have to show that. See now, this automatically, see, you have to learn how to. This bond, you show this like this, okay. So that means the bond electron come to oxygen. So what will happen? C, H, here, O, H, and now this positive charge will be moving, CH3 plus H plus. Once you show that bond electron is coming to oxygen atom, understood that H is going without electron, H plus. You look at the first step, H plus was entering, the protonation we wrote. Now deprotonation. Now overall product is formed. This only alcohol. The product I have written in different pattern, but not necessarily any direction you can write. Only you have to understand. So here this product is, this is CH3. Okay, this CH3, and after that CH2, this CH2, this CH2, and then OH. See, ethanol you got. So product is alcohol you got, and proton went out. That is why it is acid catalyst. Means H plus is the acid. It entered in the first step and going out in the last step. So overall net effect is, what is that? Not used in chemical reaction. That is why when I was explaining you about the catalyst definition, in lower classes you will study in 7th, 8th, 9th and all, you will study that it is a third substance. It is a third substance which will be physically present, will not take part in chemical reaction, it will change the speed of the reaction, like that you have studied. But in 11th and all, whenever the discussion came, I have told you it will sometimes in organic reaction, it will take part. Overall, it will take part. Without that reaction cannot take place. In chemical reaction, it will take place, but it will take part. But only thing is, after initially it will join and it will perform the reaction. At last, it will go out. Overall, it is not used. That is why we call it as a catalyst. Okay, so write down all of you. And now you take one homework. You practice this mechanism. You write down that. Write the mechanism. Write the mechanism for the hydration of propene. Okay, hydration of propene. It is not simple, but I am giving that because last year in 11th standard, I have taught you that mechanism of Markovnikov solution. Because now this propene versus water is Markovnikov solution. And there is a possibility. So you will need to show 2 carbocation possibility. In this I did not show, but you try. 2 carbocation possibility will come, and you have to choose based on the stability. And stability order, if you want, you have forgotten means write down the tertiary carbocation is more stable than secondary carbocation, which is more stable than primary carbocation, which is more stable than methyl carbocation. Okay, this is the carbocation stability. So you will get 2 possibility of carbocation. One will be secondary, one will be primary, and definitely secondary is stable. So you leave the primary and proceed with the secondary in doing the mechanism. Okay, so all of you write the mechanism, not now. Take it as a home assignment. Okay, so now let us move on to this. Next method here, no points to be written. Okay. Now next method is hydroboration. This is the same thing from alkene only. Hydroboration and oxidation. Hydroboration and oxidation. Okay. So in this hydroboration, we'll be using this addition on borane. Borane means all of you know that is. I'll show the reaction. Okay, CH3, CH double bond CH2. Here I'm taking propane. Okay, propane. I'll show how the reaction will take place. That is BH3. BH3 is not stable. You know it is B2H6 diborate, but it is in a dimer. It is existing because of extra more stability. Otherwise, in reaction, you can show that what is that borane single molecule, and this boration. This first reaction is boration. Means in borane addition, borane will be added here. We can say because double bond is there, so borane will be added. How it is added? See, I will show that if there is a double bond, first you understand this one, and here you take the only one BH bond I am showing. Only one BH bond I am showing. So now what will happen? This bond will break. This bond will break, and even this bond also should break, and H will be added. So what you will get is C, one bond will be remaining. Here hydrogen, here BH2. What is this? Is it because BH3 only one BH bond I showed? This is one thing, right? And similarly now what will happen in this another one BH bond is there. Okay, so now I am coming to B. Here one C double bond that is C joined. Now H2 was there, so similarly here and another BH bond here one C will join, and here one. I hope that you have understood. Okay, so one BH bond I have shown. Similarly, in all the BH bond will be added on the this one. Okay, so here and I instead of now I think I'll remove this. Yes, you have to go for the complete reaction just to make you to understand. And by God, but is to some extent you can understand some reaction, not like inorganic the portion. Inorganic portion, though you have to completely by God most of the reactions. Okay, so now this is the alkane. It is going to get added up here. So can you write the addition product? See, I am writing P, and here one this carbon. Okay, this carbon C single bond C, and this is CH2, and this is CH, and this is CH3, and here similarly CH2, CH. I think one hydrogen will be added here, so CH2, CH2, CH3, and here also CH2, CH2, CH3. In our textbook, if you see, it's only written as CH3, CH2, CH2 thrice B. It is written, but I have shown you in a better manner that each BH bond is getting added up. Okay, so now what happened? This one, next step is this is called what is that? Hydroboration over. Now hydroboration, that means that the borane is adding on this double bond. When one side hydrogen, one side borane group adding H, BH2 adding, that is HB. That is why hydroboration. One side hydrogen, one side boron atom attached with the other species. So hydroboration. After that, oxidation. Okay, so oxidation in the presence of alkaline medium. Then don't forget that here we are using H2O2 hydrogen peroxide as an oxidizing agent. OH minus represents basic medium. Just you are doing hydrolysis. So what you will get? CH3, CH2, CH2. In this bond will break. Here OH will be added on oxidation, on not hydrolysis, on oxidation. So this is 3 moles were getting added. Now you will get 3 moles of this alcohol. Okay. Now can anyone tell me what is the difference between already one alcohol preparation same by adding water, but now also by adding water? What is the difference? The first one is according to Markovnik's addition. So here almost equal to name reaction, like the Friedel-Crafts reaction, Woods reaction, and Rosenman reduction, like that, Sandmeyer's reaction, Finkelstein, Schwartz, like that. Now, that is this also equal to that name reaction. Directly, many times they are asked to explain hydroboration oxidation reaction. You should remember for that purpose you have to study. Another one is anti-Markovnikov's manner that reaction. Okay, so now overall you think about that. I have shown you the two steps, but overall what has happened? All of you just look at this. See, this is the alkane, and here the product is this one. What has happened? The double bond here, the double bond disappeared. One hydrogen extra came, one OH extra came. That means plus H2O. That is why it is also hydration only, but hydration taking place indirectly, that is through hydroboration and oxidation. Otherwise, overall reaction is hydration. That is why the starting material is alkene. That is why that given under preparation from alkene by hydroboration and oxidation. Okay, so a few points I have to write down. Just write down note number one. This addition is according to anti-Markovnikov's addition. And the second point you just write down, pH3 acts as an electrophile. Okay, pH3 acts as an electrophile, acts as an electrophile. I don't want to come that way if you may. Those who can pick up that, you just understand, just you remember. Otherwise, to that much extent, I didn't go. But you should, all of you should develop that much understanding here, because we have that much slowly we are teaching organic chemistry, so all basics are given. But how much you understood in class 11th, that will help you now. The extra you have to study names and other things. See that now. What is the meaning of, see the H2 plus and H minus? Then only this reaction, see the reaction though taking place, this is reality. This is reality. Reaction is taking place. No? That is reality. But according to if you, and the product is formed, the reality, the product is formed. When you studied, it was this product, according to anti-Markovnikov's addition. You did not use any, this one, only that peroxide in the beginning. After that, hydrogen peroxide is used only for oxidation purpose. Okay, and to break the bond and to attach OH in a basic medium, right? But here it is understood once this product is formed, definitely, that is why this one, see, boron is acting as a, this boron group is acting as a electrophile. Then only you see that now I am showing the three carbon atom double bond is there. So once this is the side boron is attached. You see that, look at that explanation what I gave. This is the place boron is attached. Then boron means that pH2. And here only hydrogen is attached. That means how it is possible? That is possible only when this is positive charge. Then what happened? The double bond will go. This double when this, as per the mechanism you have studied, this when you are writing this single bond, and then that what happened? Just now you wrote the mechanism. The positive charge will develop here. Then you may ask that, sir, why can't this attack here in this double bond here BH2? Yes, that's what I'm telling. If it is electrophile only, this will be stable. If it is attacking here positive charge will be developed. This is primary carbocation. This is secondary carbocation. Okay, so this is more stable, therefore more stable. Therefore, this only will form. This will not form. This is only forming, and then hydrogen in the form of H minus it is attached. That is the reason. That is the thing that reality this reaction took place in this pattern. So according to this reaction, you should note a point that BH2 act as a electrophile. Okay, so just write down. There is a boron. Boron acts as an electrophile. Electron that is because you know it's the electron deficient species. So no need to worry about the electron deficient species. So it acts as an electrophile. Okay. And boron that's attached to the sp2 carbon carrying more number of hydrogen. That is not a matter. That I already explained to you. Right. Now next second method of preparation. Second method of preparation is from carbonyl compounds. From carbonyl compounds. What is total carbonyl compound? Tell me. Carbonyl compounds are aldehydes and ketones. Okay, it's a very important question, sir. You also may like to ask, but I will answer that during the carboxylic acid discussion. That is, why is that carboxylic acid is also having carbon double bond O. Then it is not called as a carbonyl compound. And that time we will give you by using resonance and all. We will tell you. Okay, so here see carbon having double bond. So two valencies are left. Okay, so one valency is R and one valency is H. Okay, so another one is carbon having double bond O. This is carbonyl group. One valency is hydrogen, another valency also hydrogen. Carbon with oxygen double bond. This is carbonyl group. One valency is R, another valency also R. That means you know that the first two are aldehydes. Okay, so these two are aldehyde. The first member of aldehyde, formaldehyde. Then remaining R will be any aldehyde of longer chain, aldehyde. And both the side are meant and what is that ketone. Okay. So now tell me what will happen now. Now what will happen? See that now if suppose this is reduced because by reduction only I already taught you the sequence of reaction. Once again after that I will tell you. This is R C H 2 OH. This group number same number of carbon atom will be there. Okay, same number of carbon atom. Carbon will not become less. And here what happened in this? If you carry out the reduction means nascent hydrogen if you supply, what happened? So here this is the one. Here I used to show in this carbon one hydrogen will be supplied, oxygen one hydrogen will be supplied, the bond will break. So R C R here one hydrogen and here O with O one hydrogen. This is secondary alcohol. Secondary alcohol. Here see that here one hydrogen. Already one hydrogen is there, one more hydrogen is CH2 and this single bond, then it will become OH. This is the thing. So both the side two hydrogen, nascent hydrogen will be supplied. And this is primary alcohol. This is how you have to study. Okay, write down that from carbonyl compound, there are two carbonyl compound, one is aldehyde and ketone. Aldehyde will give on reduction, it will give primary alcohol. The pattern of reduction will be two nascent hydrogen on that C double bond O, that double bond, two hydrogen, nascent hydrogen will be added. Okay, so now once it is nascent hydrogen, who all will give the nascent hydrogen in the previous chapter itself? I gave you plenty of reagent. I gave you, and you can just note down those reagents. What is that? Zinc hydrochloric acid, tin hydrochloric acid, sodium ethanol. Why with the sodium hydrochloric acid combination is not given? Anybody? Zinc hydrochloric acid, tin hydrochloric acid will produce nascent hydrogen. Okay. So why not sodium and hydrochloric acid? Why sodium they have given ethanol? Anybody? This all easily you should have the ability to think. The purpose is they will react and they will produce nascent hydrogen. See that HCl is that. HCl, any metal is reacting means what happens that metal chloride will form. So MCl or MCl2 as per the valency MCl3 or M2Cl or whatever it is. Then sorry M2Cl will not come, M2Cl4 or whatever is that. Here H will be abandoned and now nobody is there to react means two hydrogen will form hydrogen gas. That's what you have studied in lower classes. When your metal is dropped inside hydrochloric acid or any acid, that hydrogen gas will break down because nobody is there. But now inside, suppose one aldehyde is there. Inside one aldehyde is there or some ketone is there, that this hydrogen will directly attack that. That's why we say newly born on the spot produced. Okay, nascent hydrogen means new born hydrogen. Not only we say nascent hydrogen. Otherwise, it is nothing but hydrogen atom. So don't think there's a special kind of hydrogen atom is nascent hydrogen. No, new born means on the spot produced. So we call it as the meaning of nascent. The word is new born. That is on the spot produced. It is a normal hydrogen atom. It is highly reactive. Atomic hydrogen is not stable. Highly reactive, it will attack. Okay, so here there is a double bond unsaturation. So here one hydrogen, here one hydrogen will be added, and this double bond will disappear. So or CH2OH you are getting. In case the ketone, you are getting secondary alcohol you are getting. Okay, so write down that reagents, what all reagents you can use for this. And this first one is generally right lithium aluminum hydride. Okay, this is a very organic synthesis, any reduction. Okay, reduction up to alcohol severe reduction means you can use that. And sodium borohydride. These are very important reducing agent. Remember that. But this do not use this anywhere when you, because after completing all the chapter, you will start writing equation yourself. You will start applying the different chemical reagents yourself. That time you keep a point in your mind. These chemicals you do not use for partial reduction. Partial reduction. What is partial reduction? See that the COOH, carboxylic acid, you have to convert it into CHO. This is here you don't use this. Here you don't use this because it is a strong one. It will, if you use this one directly, it will take you to CH2OH because this is the last extreme. After that, it has to become hydrocarbon, but that is only by special reagents. It will not happen. That is HI. You have to heat it with HI, then only that it will be converted into hydrocarbon. But otherwise, in all ordinary reducing agent, if you use, this is the last step. But if you want to stop, see here, this is the second step. So our carboxylic acid up to aldehyde or carboxylic acid up to ketone mean it is a partial reduction. That time you don't use this lithium aluminum hydride. There you will use some what is that? This one you will use some less effective. Some that is special purpose. Those reagents you have to remember. In one of the Rosenman reduction, there will be a partial reduction that I might explain once again. In many places will come. Okay, so lithium aluminum hydride and sodium, or another one is hydrogen plus platinum or palladium or nickel. This also can be used because it is a hydrogen, and many more. Sodium ethanol. I don't want to give every time. So you don't think what I am conveying to you is, don't think that sir, can we use any one of those we studied in the previous chapter? Yes, this reduction you can, because you need nasal hydrogen means you can use any one of these. All of them will provide. Okay, so tin SN HCl, zinc HCl, sodium ethanol. And you did not answer my question. Why sodium ethanol? Why not sodium hydrochloric acid? Any one of you? Right? Tell me. If you have no idea, tell me no idea. That's nobody can think of that. And see that the purpose is H plus production. For that only I came and I forgot it. See, sodium, you know that already by nature, it is a very, very highly reactive metal. Even it reacts with water. Then you think about if water itself, it is explosive. You can see that I have told you, it will burn with flame and floating on that, reacting vigorously with a lot of bubbles will come out. And that much highly reactive in cold water, it is reacting vigorously. When you think about acid, in acid just it is splash out means what? It is uncontrollable reaction. So we go for a weak acid, that is a C2H5OH. It is alcohols are actually alcohols are almost neutral. Just for acidic comparison purpose, you will study they are less acidic. But actually alcohols are almost very, very, very weak acids. Okay, so that means this will be removed. Sodium is a base, that means Na will come here, sodium ethoxide C2H5O Na, sodium ethoxide plus hydrogen. 2 means here 2 hydrogen. Nobody is there means it will become H2 gas. If it is something is there, they will attack. Okay, so that is the thing. And zinc, why we are using zinc? Zinc plus HCl, because zinc is not a very reactive metal, moderate reactive metal. Tin. So we are using such a thing because one side is highly reactive, so less reactive will work out. Here it is highly reactive, less reactive. Ethanol you have taken. Both more reactive means what the reaction will be very violent, vigorous, and that will not it will not be convenient to carry out. Okay, so right. Carbonyl compound. One is reduction from carbonyl compound. Okay, one more is reduction of carboxylic acid. Right, under the same heading, reduction of reduction of carboxylic acid and ester. Right now, reduction of carboxylic acid and ester. Here I just write that as equation COOH will be reduced. I told you that in a severe reduction, no need to use the partial reducing agent. Reduction symbol is H. So here R CH2 OH. CH2 OH. Is it same as this is R and this is OH. Okay, so now you look at this. Here what has happened? This what has happened? This CO bond is broken. CO bond is broken and two valency lost, so two hydrogen separate. See RCH2OH. You see RC. So the pattern of reduction is different. In the previous one, what happened? Only one pi bond. It is very simple. Pi bond. Pi bond was broken. Here one hydrogen. Here one hydrogen. Very simple. The pi bonds are already weak. Whereas here, it is not pi bond, completely broken. Both the bonds, sigma bond and pi bond broken. Here two valency last mean both are satisfied by hydrogen. That has happened. Understand? So that's why we are studying separately. Otherwise, though, I could have included that itself if it is same type. So here, reduction of carboxylic acid. Ester also same. Ester is what? C double bond O. Instead of OH, here it is OR. So this is R. So now here it will be forming this, the different product will be forming. And now see, write down this reducing agent, you write down lithium aluminum hydride. So here how to write? Here you have to write, I told you, you put one lithium aluminum hydride and the two also you have to write, because whenever this, because this lithium and aluminum are not strong metals. Okay, it's not very low reactive. They are somewhat reactive metal. So what will happen? RCH2 OH, na, that OLI or O thrice AL, that will be there. So for that, what you have to do? You have to do hydrolysis, acid acidification you have to do. So there is second one is H plus slash H2O, or you can use that symbol H3O plus. Is also acid hydrolysis. Okay, so this one is first step, two is second step. The same arrow mark you can use, but don't forget to write 1, 2, because it is taking place in two steps. And this one you remember, just in that notebook somewhere you write, or if you are using textbook, you write down, because you will forget. Whenever a metal is involved in the reagent, reactive metals are involved, then it has to be hydrolyzed, acidified, acid hydrolyzed, because the salt will form. Even if it is COOH product also, this will be metal will come. If it is COH also, this H will be metal will come. So definitely you have to do one step, that is hydrolysis. Don't forget. So you write it as a notes in somewhere. Okay. Whenever there is a strong metal involved in the reagent, you wait and see. In many places it will come. That time you will understand what I have told you to note down. Whenever the reagent contains reactive metals, then you have to do hydrolysis at last, because in case of these acids, alcohols and all, that the H will be replaced by the metal. So to recover the hydrogen, you have to do acid hydrolysis, that is called acidification. Right? Write down. Here again, one below this reaction, you write down one more reaction, CH3COO C2H5. You write down CH3COO C2H5. Can anyone tell me the IUPAC name of this? Ester? CH3COO C2H5 or CH3COO CH2CH3, or CH3C double bond O CH2 CH3. So definitely you should not take this as a root word. Whenever this Carbon double bond. This all why I am giving this all a simple thing. Many of you, even if you hear out of this, more than 75% you do not know this. You have a doubt and all. So this CO, this CO double bond owner, that carbon is attached where that is the acid name. This is the alkyl group. This is ethyl. Ethyl. This is 2 ethanoate. Ethyl ethanoate is the IUPAC name. See, ethyl ethanoate. Ethyl ethanoate. Sir, why you are not writing number? Because ethanoate means only 2 carbon, any one side, both are same. Okay? And even COOH group will be always in the terminal. So no need to write one OH. One OH, no need to write. If you write also not understand. Okay, so here this one will be undergoing reduction. And what will be the product? CH3, that is CH2OH. Okay, so this acid group will become CH2OH. So CH3, CH2OH. Understand? Here also C2H5, and again another one molecule. So 2 moles. This also will be formed as. So the totally 2 moles will get. One is from acid part, one is from that alkyl group. Okay. So here note, you write down the note. Write down. Carboxylic acid give good yield by lithium aluminum hydride LiAlH4. Carboxylic acid give. This whenever why I am giving this note and all, not for simply wasting time and all. This will be definitely helpful for listening question. You saw, see that old question, you see that what all I am covering in this, because otherwise only equation alone. But everywhere, every time in the board exam, the listening questions are asked. So wherever I am that note I am giving, that point will be useful for writing the answer for listening question. Okay, carboxylic acid give good yield by lithium aluminum hydride. Okay, lithium aluminum hydride reducing agent will give a good yield for carboxylic acid reduction. Okay, but still this is a very expensive reagent. This is a very expensive reagent. This is a very expensive reagent. Therefore, therefore, we will convert the this into ester. Carboxylic acid will be converted into ester by treating with alcohol. Okay, because alcohol is super 1 and this one, and then we will reduce into CH2OH. Okay, by hydrogen and then hydrogen palladium. Hydrogen in the presence of palladium. So this point you write down as a note. Okay, why carboxylic acid is not directly reduced to alcohol by using lithium aluminum hydride? You are right, it is highly expensive reagent. Therefore, we will go for a cheaper method, that is convert this carboxylic acid into ester, and that ester can be reduced by hydrogen and palladium and easily taking place. Whereas the hydrogen and palladium cannot be reducing, it cannot be used for reducing, because I told you that reduction here is very severe reduction. The next reaction is very, very important. That is from Grignard reagent. And this once again in the third chapter, this will come in the properties. I think without that properties it is difficult, but still I will try that to let's say explain some extent. And this is the third preparation from Grignard reagent or MgBr. Okay, here the covalent bond, R and magnesium covalent bond, highly polar. Okay, organometallic compound where metal is having a covalent linkages, that is Grignard reagent. Ionic linkage, though many compounds are there. Right. Now, here actually to whom it is going to react? It is going to react with carbonyl compound, aldehyde and ketone. Remember that. Then it is, sir, why then it is not included in the second heading? Second heading is from carbonyl compound only. Yes, carbonyl compound. But here the reagent is RMGPR. But since it is a very important reagent, there is a speciality in this reaction. So I have taken. What is the speciality? I will tell you later on. I will explain only one by using the backbone, then you are going to complete 3 examples now itself. Okay, not that homework. So what I will do is I will use only carbon oxygen double bond, the 2 different valencies. Okay, that's all. This is carbonyl. This is aldehyde. It may be aldehyde or it may be ketone, carbonyl compound. Okay. And what happens here? We will use the reagent RMGBR, Grignard reagent, right? Okay. Or if you want, even I will take this. Because I cannot give everywhere. I cannot give. Here I am writing CH3. Okay. Alkyl group also I am writing CH3 MgBr. Right now, how the reaction will take place? One step, and after that, the next step will be. Can anyone tell me what is the next step? Can anyone tell me next step? Right, tell me. Just now I told you
I
H
don't know.
plus H2. Why?
I don't
Because
know.
magnesium reagent contain magnesium reactive metal. Remember that. Okay, so here, see, I am separately showing here this carbon oxygen double bond. You all of you know pi bond is weaker bond. Okay, when compared to sigma bond. In addition to that, carbon is very less electronegative when compared to oxygen. So definitely there will be a high rich positive feeling, negative feeling. Means it is a highly polar bond. That is a pi bond. Sigma bond goes strongly held and all. If pi bond is already weaker by sidewise overlapping. In that particular the pi bond electron, 2 electrons will be always spending time with oxygen. Because pi bond means loosely overlap. Pi overlapping is loose overlap. Pi bond is loose. And then in addition to that, oxygen is very much more electronegative than carbon means because second highest electronegative oxygen. So that the electron cloud will be always, this electron cloud will be always here. It is electron cloud if you want to say, you have to draw like this. That means delta minus delta plus, highly polar bond. So this kind. Another one come to this side. The reagent side also what is this metal highly electropositive, and this when compared to metal, carbon is more electronegative. When compared to oxygen, carbon is electropositive, like positive feeling only different. But when compared to magnesium, when compared to magnesium, this carbon is very highly electronegative. So here the electron cloud in this covalent bond will be towards carbon. So positive. See now see carbon, oxygen. The double bond I am not showing. Here delta plus, this is delta minus double bond is there. So now this who will attack here? Tell me who will attack here? Double bond I am not showing because something is going to be added. So who will attack here? Positive charge will be attacked by whom? That is
Or
CH3 or CH3. And here what will come?
Mg.
Mg attached with the Br. See now I am writing here. See that a carbon, 2 valencies I am leaving, 2 valencies, and 1 valency here, 1 valency here. In the 1 valency is that R will be added here. Understand and right? And here oxygen is already there. Now with oxygen, MgBr will be added. And now when you hydrolyze, what happens? Carbon, the 2 valency, and one is CH3 added newly, and this O H will become, see, alcohol. Alcohol form. Very simple. Can anyone tell me what is the speciality of this reaction? What is the speciality of this reaction? It is very important because it is almost again, it is even more important than name reactions. And this reaction is very much useful in some cases. You will not be able to carry out the conversion if you do not answer my question, what I am asking now. What is the importance of this reaction? Just to tell, whenever I ask the importance, you just look at the reactant and the product. Look at the reactant. Reactant is carbonyl compound. Okay, carbonyl compound. And here product is alcohol. You tell me what is that? Write down. This much time is required or not? Write down that note. Alcohol with more number of carbon atoms can be prepared by this method. Why I'm writing more number of carbon? Why I don't say one more carbon? Here only one carbon. But CH3, if you take C2H5, two carbon will be more. Here it will come C2H5. If you take C3H7, then here it will be C3H7 will come. So that means one carbon more, two carbons more, three carbons more. So more number of carbon atoms can be prepared by this method. And that point is not all important. Aldehyde converted into alcohol. See, that question will be asked here. See, one question you, not for solving. Suppose I am asking a question, how will you convert acetaldehyde into propyl chloride? The N-propyl chloride. Or whatever that actually acetaldehyde will be, yes, that is CH3 means isopropyl chloride. This is a very good question. Acetaldehyde, I am removing this page here, just to understand how you have to think. Learn that systematic method. See, my question is acetaldehyde. Question is in the exam acetaldehyde. How will you convert acetaldehyde into isopropyl chloride or bromide? Isopropyl chloride or bromide. Okay, now immediately I told you, that's why I told you, you should know the structural formula. Acetaldehyde is CH3CHO. CH3, in mind you have to think like this, CH3, C double bond O, H. That means it is a something carbonyl group. Here only reaction will operate. Right? That is one idea. Then isopropyl aldehyde means energy means CH3, CH3, here chlorine. See, that means, see here, what you have to understand, yes, there is here CH3, here there is here CH3, and there is one carbon with oxygen which can be converted into alcohol later on. So this carbon also there. That means one extra carbon methyl group has come. Immediately you should come to your mind that is methyl magnesium bromide should have been one of the most of the cases. Methyl magnesium bromide could have been used because here another one is carbonyl group. So this carbonyl group and CH3 MgBr, and what happened? This CH3 will be added here and MgBr will be added in oxygen. Hydrolysis will give what? Hydrolysis will give OH here. Here CH3 will be added, and then this is old CH3. Okay, old CH3, and one hydrogen also here. Old hydrogen is already there. This hydrogen. Okay, so that means, see, now you see somewhat. Only thing is what now, sir, you have to convert this into chlorine. That though you know SOCl2, phenyl chloride is a very suitable. Or you can go for PCl3. You can go for HCl, zinc, anhydrous zinc chloride. Many things I gave you. This is how you have to think. So always you write the reactant and the product and see the difference. The difference itself will give you some idea, yes, how this reaction can be written. Okay, so then whenever the carbon atom is more, then only you can restrict your, no need to think very broad term, because increasing carbon atom is done by few reaction. One is Woods reaction. In Woods reaction, double the number. Always double the number, or one phenyl group and one aliphatic, like that. That is Woods fittics. And here another one is this one, whether methyl group or ethyl group, whichever you want, you can easily increase. But that this is Grignard reagent is for carbonyl group, carbon double bond O. That you remember in your mind. In some alkyl cadmium, some reagents will come later on. Hardly 2-3 reactions are there which will increase the carbon atom. There are some reactions which will reduce the carbon atom also, like decarboxylation, alcoholic KOH. You already studied last year in preparation of methane. In tension also you have studied. Decarboxylation. There are here this year you will study some new Hoffman bromamide degradation. Carbon will be less. So some reaction carbon more, some reaction carbon less. There are few number which is very, very essential for you to remember, because that will help you a lot in such dealing with such conversion. Okay, all of you understood? So write down. Okay, now what is my question is that you are now, I just told you that I explained you with the help of some two valency left like that. Now all of you carry out this reaction. starting with formaldehyde, acetaldehyde, and acetone. One ketone, two aldehyde, because one formaldehyde is, then this is CH, C double bond O H. You start this with CH3 MgBr. Everything you take CH3 MgBr. And after that you try, because I want to comment on the conclude on this product form. Okay, this is acetaldehyde. This I already did, but one more time you write. So CH3 MgBr. Okay, write the product. Then again do the hydrolysis and write the product. So here it is H plus H2O hydrolysis, right? And similarly acetone CH3 C double bond O CH3. So best always learn. Now I wrote like this, but because you people also should learn slowly. So here what you do, always have a habit of writing carbon here, hydrogen this side, carbon here, hydrogen this side. See, carbon carbon bond is very clear. Here also CH3 MgBr. Okay, so this is the thing. Okay, I want to conclude. This is formaldehyde. Formaldehyde. This is acetaldehyde, but not only acetaldehyde. This is any other aldehyde, any aldehyde other than formaldehyde. Okay, and this is any ketone. I have taken the first member acetone, but it is any ketone, this same thing. Same thing will happen. Okay, right. So formaldehyde, what happens? Acetaldehyde, what happens? And ketone, what happens? Means formaldehyde, other aldehydes. Any ketone. Three cases I am going to conclude. Not necessarily that I have to conclude. You yourself can write the conclusion. Can anyone tell me what is happening in the formaldehyde case?
Ethanol.
Ethanol. Okay. What is that? Ethanol is a common name is what? What alcohol? Ethanol is common name is what alcohol? Tell me. Ethanol is having alcohol attached to where? One, are you having this alcohol attached CH2OH? What I told you, let it be ethanol, anything. But this is what it is. CH2OH means what alcohol it is? Primary alcohol. And write down that primary alcohol. So formaldehyde will form primary alcohol. And you check now acetaldehyde, any other aldehyde. Example is acetaldehyde, but it is representing any other aldehyde other than formaldehyde, all aldehydes. What is the alcohol you are getting? What is the alcohol you are getting? Check up
Secondary.
that. You will get CH only will get, because here one branch will come, here one branch. So this is secondary alcohol you are getting. So write down. Other than formaldehyde, higher aldehyde will give secondary alcohol. And ketone, I think definitely will have a tertiary alcohol, because already two methyl groups are there. See, two methyl groups. And from Grignard reagent, one more methyl group will come. So only that OH will be attached. Already two methyl group, one more methyl group will come from Grignard reagent. Okay, so what is this? This is tertiary alcohol. Okay, so this is what required here. Simply, you see, if I don't say this, or if you do not note down this, then it will not be very much useful to you. How many you will by heart? Plenty of full equation. It has each and every page of organic chemistry, full equations. So, a certain extent, you have to understand and write. Okay, because they are not going to ask you that how will you prepare, give any method of preparation, not like that. They will always ask convert A into B, convert X into Y. How will you prepare A from B? How will you prepare C from B? Either only they'll ask. So conversion, not one step, it may be two step, three step. For that you have to develop this idea. So remember, now you keep on, you have to remember this. Yes, aldehyde to alcohol. Okay, increase more number of, write down that aldehyde to alcohol or ketone to alcohol. This is the point you have to study. Aldehyde to alcohol, ketone to alcohol with more number of carbon. With more number of carbon, this is via Grignard reagent. This is actually called, that is actually called, what is that? Nucleophilic addition. That I will not explain now. The same reaction is a very important discussion in the first chemical property of aldehyde chapter. Aldehyde ketone, next chapter. That time I will explain, spending a lot of time on that. Why it is called nucleophilic addition, though you understand, because one side CH3 is added, another side MgBr is added in the double bond. So double bond addition takes place. But in nucleophilic addition, why nucleophilic addition? There we will discuss. Here that will be up to have the discussion. And now write down. And one point is more number of carbon atom alcohol. And another one is formaldehyde will give primary alcohol, other aldehyde will give secondary alcohol, and ketones, any ketone will give tertiary alcohol. This point also you write down. This point also write down. Okay. Okay. I think I don't want to waste your it's not wasting time, but you may be waiting for to leave. So now we'll continue tomorrow. That heading, write out the heading, preparation of phenol. Only 3, 4 reactions are there. Shall we complete now or we'll continue next class?
Next class.
Next class. What about others here? Always only one person is talking. About
Next
27 are
class.
here. Next class. Because if you see only one person is saying next class, I will take it as the remaining 25 or whatever is that remaining strength wants. And tell me, today or tomorrow will continue.
Tomorrow, sir.
Tomorrow, sir.
Tomorrow, sir.
Tomorrow, sir.
Tomorrow, sir.
3,
Tomorrow, sir.
4, 5, 6. That means
Tomorrow.
other than 6 or 7.
Tomorrow,
Tomorrow,
sir.
sir.
Tomorrow, sir.
Okay.
Tomorrow,
Right.
sir.
Don't waste my time.
Tomorrow.
So tomorrow we'll
Tomorrow.
continue, but write the heading preparation of phenol. Tomorrow we'll complete preparation of phenol and all the chemical properties. Then another one day with the ether. That will be proper study. And anyway, today itself I will try to send one more homework that from the previous chapter, halogen chapter, and this up to what is taught. I will just check that what type of conversion can be accommodated within what is studied for by you. Accordingly, I give some assignment, then you try to convert and see. Okay, that type of practice you have to take. Right. Anything else you see that I don't pose here, I will just tell you that because it is not necessary for completely CBSE, and but those who are preparing for this need sometimes need to some extent, mostly for the day and all that. That one reaction I had, you did not ask me any question. What is that? That is, sir, number of how to find out the number of optical isomers. Okay, so that alone I will just explain and just you go for that. There are 3 different formula I will give you. One is the first one is if the molecule is not having no molecule is having no symmetry element. No symmetry element. What is the meaning of symmetry element? The plane of symmetry, mainly plane of symmetry, line of symmetry, like that you have studied in mathematics. If the molecule is not having any symmetry element, that number of number of optically active isomer will be equal to 2 to the power n. Okay, where N stands for number of chiral carbon. Number of chiral carbon. Chiral carbon is asymmetric carbon. Number of chiral carbon atom. Number of chiral carbon atoms. Okay, so this is first formula. Second one is suppose when the molecule is having symmetric molecule has symmetry element. Symmetry element. That is, I will tell you what is symmetry element. That is the plane of symmetry. Molecule has symmetry element. Here there are 2 cases. One is A and another one is B. That is that n is equal to odd and n is equal to even. What is n? N is number of chiral carbon. Okay, number of chiral carbon atoms. So see that the first formula is only when no symmetry is there. It is asymmetric molecule. The meaning is the molecule is asymmetric. asymmetric molecule. There is no symmetry in that. Okay, no plane of symmetry, line of symmetry category. Right? That time use this formula, very simple. Number of optical isomer, this one. But when it is having the symmetry element, there is a plane of symmetry. Plane of symmetry means that plane, if you imagine, the top of the plane and the bottom of the plane will be mirror images. That type of one arrangement configuration. I will give an example after giving the formula. You copy down, I will give an example. I need to explain what is the mesoform also. Yeah. Right? Okay. So when they have a symmetry element, there are two chances. One is that the number of chiral carbon will be odd number. That odd number means and one though not I start from three because one is that that also right now. Whenever only any molecule is having only one chiral carbon, it is always and every time the first category. It will never have symmetry. Okay, remember that. When a molecule contains only one chiral carbon atom, when a molecule contains only one chiral carbon atom, it will always be asymmetric. It will be always be asymmetric. No symmetry will be there. Okay, and if it is 2, 3, 4 only, there is a chance for symmetry. So here the odd means 3, 5, 7, like that. Here even means what? 2, 4, 6, like that. That is it. So in that time, here that optical isomer, optical reactive isomer, optically active isomer. In another one is isomer, but optically inactive. That is called as mesoform. So mesoform will be actually optically inactive. So I don't know why I am writing optically inactive, but that is mesoform. Okay, so that means the total how many you have to find out. And same thing here also. Okay. So when that number of carbon atom is even, sorry, odd, first we will discuss odd. It is 2 to the power 2 to the power n minus 1 minus 2 to the power n minus 1 by 2. That's why I told you if you want to remember, you study. Otherwise, just for additional information, not for CBSE, I'm telling you. And the mesoform is 2 to the power n minus 1 by 2. 1 by 2. Okay, this is for odd sign. Then the same that even number means what is the mesoform? Just write down mesoform. Here it is 2 to the power n minus 1 alone. Simple formula. Here it is 2 to the power n by 2 minus 1. N by 2, yes, sorry, n minus 1. The minus is here, minus 1. Minus 1. Okay, so even number formula is simple, but here you study that more clearly. I am writing this one 2 to the power n minus 1 minus next term is 2 to the power n minus 1 divided by 2. Divided by 2 is the power. This completely power n minus 1 divided by 2. And that second term, only very simple. First formula you study, the second term is the mesoform. You see, the second term is the mesoform. So now you apply this and find out. So if they are asking number of optically active isomer, the first formula alone you substitute. But I have asked, my question is how many optical isomers will be there? So optical isomer means that first one is also optical isomer, mesoform also optical isomer. So what you have to do is both the formula you apply, find out and add, and the total will be number of optical isomer. Optically active isomer, first formula, and this mesoform optically inactive. Okay, copy down. I will come to that what is mesoform. For mesoform explanation, I will take that one tartaric acid. Okay, tartaric acid is CHOH, and CHOH. This is only tartaric acid. Okay, tartaric acid, I will go for Fischer projection formula. The Fischer projection formula is this one. This vertical line. Here, the highly oxidized from COOH, and this side one hydrogen, this side one OH. See, this is carbon. This is the intersection. That intersection, na. This is chiral carbon. This is chiral carbon. According to this, what is that? Fischer projection formula. H OH, COH. Okay, now I am drawing with the red color. You imagine a plane here, three-dimensional. Because what I have drawn is a three-dimensional. See, look at my video. Let's see that the top, that the COH, HOH will be like this, and the bottom it will be like this. Okay, but two-dimensionally visual projection formula is converting 3D into 2D by assumption, that is okay. So that is thing. So top it will be triangular like upward, bottom also like that. But these three bonds will be directly above that. The top three bond, bottom three bond will be in line. That's what I have shown here. And now in that case, if it is OH same, so means what happened? This is a plane. This is the plane of symmetry. This is the plane of symmetry. Why it is called the plane of symmetry? See that the top one is the mirror images of bottom one, or the bottom one is the mirror image of the top one. So this is called plane of symmetry. When plane of symmetry, what happens? Suppose if this is having plus 60 degree, is it this carbon atom is optically active or not? See hydrogen, OH, COOH, and the leftover. That means it is a chiral carbon. It is a chiral carbon. Chiral carbon atom will rotate. Suppose 60 degree if it is rotating. This also chiral carbon. This also chiral carbon. It will rotate. But since it is a mirror image, these two portion, not a molecule. This portion and this portion. They are in enantiomeric relationship. So if it is plus 60, it will rotate minus 60 degree. Then overall this is part of the molecule. I'm telling part of the molecule. But overall molecule, what happened? Overall molecule optical rotation is equal to 0. That means optically inactive. Optically inactive. Reason is what? Optically inactive due to internal compensation. The word in the racemic mixture, last class I used the word external compensation, because one molecule rotation will be cancelled by another molecule rotation. But here it is not like that. In one molecule itself, one portion rotation is cancelled by another portion rotation. And this is called internal compensation. Okay, so all of you write down that point, that mesoform is optically inactive. Mesoform is optically inactive due to internal compensation. It's only mesoform. Whenever there is a plane of symmetry, mesoform will be there. It will be optically active. But it is an optical isomer. Isomer different, activity is different. Isomer is same formula, different arrangement. That's all. But rotating means that is called optically active. Not rotating the plane polarized mean it is optically inactive. That's all. Optical isomer and optically active, no relation. That optical isomer is same formula, different arrangement. If it is changing the plane polarized type, rotating or active, not rotating means not active. That's all. Okay, that is why I have given two formula. One is optically active isomers, another one is mesoform. Always one mesoform will be there, some one or two. Here two asymmetric carbon. Two asymmetric carbon. So two enantiomer, one like that. I don't want to go another one term diastereomers. If you want, if you are interested, otherwise free time only I'll be able to answer. Diastereomers. The diastereomers means what? They are optical isomers, same formula, but they are not mirror images. They are not enantiomer. Optically active. Mesoform is optically inactive. But optically active, but they are not very fast. I will complete that. Anybody is interested, you stay. Otherwise, you can leave that. I will show only the diastereomers by using the same example. Okay. So see, this is COOH, H, OH, H, OH, COOH. Okay. So now what is this? It's the mirror. So the mirror means what? Now see, this is COOH, COOH, this is H, OH, H, OH. Now what is this? What is these two? These two are enantiomers. There is no plane of symmetry. You see that you imagine any plane, there is no plane of symmetry. Okay, so these two are enantiomers, optically active. One will be plus 60, another one will be minus 60. Opposite rotation. Okay, enantiomers. Okay, enantiomer. But now see, I am writing one more diagram. The same one I will convert this into. See, I will remove this enantiomer word. So I am going to show you the diastereomers. Now, what is this? Tell me, are they mirror images? Are they mirror images? You don't think that, sir, if you second one, if you reverse and all, that is three-dimensional, it will not work out. When you imagine two-dimensional phenomenon on 3D picture, it will not work out. Three-dimensional, you have to think, okay? Rotation and all will not be applicable here as you think of 2D structure. Okay, so as it is shown in the diagram, are they mirror images? See, from here to here, short distance, here short distance, here h is there, here y is there. That means not a mirror image. Okay, not a mirror image, but optically active. It will have an alpha rotation. It will have alpha rotation. Optically active, but not a mirror images, not an enantiomer. Mean now these two are cross